something, again, a little different. The next presentation we have coming up is from a company based in the US called ClearEdge3D. And primarily, their application has its feet in the, how do I describe this? The conversion work that is done with from a brownfield, greenfield to as-built drawings, scanning, and what can be done with scans, especially when the scans are incomplete and there's data. So, okay.
Thank you, Peter. I appreciate the opportunity to present. What we're going to present today is really two products. The first one we're going to go through is called EdgeWise, and EdgeWise is used for taking your scan data and extracting out an automatic 3D model. We work a number of different industries, but our focus is really oil and gas, and I'll go through that in just a few minutes. The second product is Verity, which we're going to also discuss and show, and that's for construction verification. Okay, so I'm assuming everybody could see my screen. If you can't, please let us know. Anyway, so a little bit about our company, which is ClearEdge, and the products that we have. Okay, we were founded in 2006, and from day one, we focused on automation. Our goal was to save our clients time and money. We're part of a billion-dollar company. Our goal is to reduce your modeling time by 50 to 75%. And that's pretty much expected by our clients. On the oil and gas project, we're certainly up over 50%. So if we could take your scan data, produce an automatic 3D model, and save you well over half the man hours, you're way ahead of the game. Okay, and we'll show you how that works today. The return on investment is typically easily realized on your first project. EdgeWise is easy to use and learn. Quite honestly, between an hour and a half to 2 hours, we could take you about 85% of the way to using EdgeWise. The other 15% is just by hands-on experience, okay? Because it's doing over 50% of the work, it's easy to use and learn. It's compatible with all scan files, so whether you're working with a Trimble or a Leica or whatever else, it doesn't matter to us, okay? EdgeWise is really middleware, so we don't care what scans come in, and we don't care, what goes out in terms of whether it's Plant 3D or Aviva or AutoCAD or Rivet or whatever. Okay, and we can handle both structured and unstructured scans. We also integrate seamlessly with a number of different CAD programs, including Rivet. Our portfolio really consists of basically 4 modules. Okay, so structure and building, I'll get into in a second. The difference between Plant and MEP is really there's no difference in functionality. The only difference is MEP has been specifically, heavily integrated with Rivet, and Plant is for all the other applications. Okay. So on the Plant side, we automate the pipe extraction on a project. So we'll automatically extract the piping. We give you QA tools, quality assurance tools, so you could verify the accuracy and do a quick refit if required. Basically, as fast as you could page down, you could do check the quality assurance. Again, you need to verify it very quickly, because if you spend more time verifying what was automated, it defeats the purpose of the automation. We also include ducting and cable trays. So the ducting is the round ducting, the square ducting. EdgeWise will do the transition pieces, and on the cable trays, same thing. We will do the cable trays, and EdgeWise will also do the transition pieces. Okay, we could do the vertical, the horizontal, it doesn't matter, as well as the conduits. Okay. The software is spec driven. So once you apply a spec, to the piping, it takes on everything about the spec. So it knows dimensional information. It knows the pipe size, with the OD, whatever. It'll give you all the data about the pipe based upon the spec. So when you place components, it knows what components to place, and it actually goes out and reads the spec table when you put in a valve, for example. It does come with a number of worldwide specs. So we do include like ASME, we include DIN specs, we include JIS, and a number of other specs from around the world, okay? And it's easy to create custom specs. Our spec data is in a spreadsheet, so if you can copy and paste, it's easy to create any new specs. We also provide semi-automatic editing and extraction tools. We're not going to get 100%. You're going to have pipes behind pipes, pipes behind steel. So besides the automation, the fully automatic, we also provide semi-automatic editing and extraction tools. And our smart sheet allows you to add intelligence to each pipe run. Okay, and we could export these intelligent pipe models to various CAD software programs. The ones that we support out of the box are CADWorks, which is Intergraph, AutoCAD, Plant3D, Aviva PDMS. We're currently working on an E3D plugin as well. We have a structural beta available right now, and we will have a piping beta out in August, early August. Okay, so we're working on E3D. We also support AutoPlant, which is a Bentley product, and we support generic Rivet, AutoCAD, MicroStation, STEP, and a number of other export formats as well. Okay. On the MEP, it's identical to Plant. The only difference is it's for rivets. Okay. On the building side, we automatically extract the walls, and we could export it to Rivet as intelligent Rivet family objects. And what EdgeWise extracts is the as-is condition as opposed to as designed. Walls typically are not straight. They're not necessarily 90 degrees. They may be 89.2, 91.6, whatever. EdgeWise will give you the exact as-is condition. Okay. And again, QA is important to us, so we give extensive QA in editing tools. In fact, if you're using Rivet, you'll see actually a pull-down menu on the Rivet ribbon for EdgeWise. Okay. On the structural side, we could model steel, concrete, and wood. There's no need to clean the point cloud in order to extract any structural components, because you tell EdgeWise which catalog you're using. EdgeWise will go out, use the data from that catalog, and extract the elements based on that catalog. Okay. And again, QA is critical to us. We will show you exactly, the point cloud and the steel that was extracted and how it matches up. And again, as fast as you could page down, you'll be able to do QA. Now, on the structural side, the piping automation happens on a front end. The structural automation's on a back end. So we have a gridded pattern. So basically what that means is if you have a pipe rack, you would extract the elements for one of the vents, and then you would tell EdgeWise what the pattern is, and EdgeWise will go out and extract the rest of the steel automatically. And again, we could export that directly into CAD or Rivet as intelligent objects. So on that note, I'm going to turn it over to Trevor, and Trevor's going to take us through a EdgeWise demo, and then I'll come back and we'll talk about Verity and how that works. Okay, so Trevor, I'll turn it over to you. Okay, so a little bit about Verity. What we found before we developed Verity were there were a lot of industry challenges in the construction industry, right? There was really no accountable quality assurance and quality control construction process. So Verity we started developing in about 2015, 2016. And what we found is that by having, QA, QC processes, clients could minimize, mistakes, waste, and rework. Okay. So what we found is that rework could average, depending upon the size of the project, almost 20% of the project and schedule overruns, which is substantial. We figured there's about, based upon industry research, there's at least $450 billion in lost profit to the industry. We think that's very conservative. It's probably double, maybe even more than that. That's a lot of losses to the construction industry. So what typically happens is your design and your as-built is a mismatch, right? So today, the job sites require better communication than ever before, right? 30 years ago, we built buildings that were pretty much standard buildings, right? One floor on top of another one. Today, we've got all sorts of unusual construction. We got cantilever buildings, we got pyramid buildings, we got triangular buildings. So the communication is more critical than it's ever been. And what happens is your as-built construction many times is different from your actual design plan. So how do we manage that to minimize cost and schedule overruns? So really what we want to do is we want to eliminate these type of mistakes that happen in the field. So by having tighter communication and bringing out and showing you potential problem areas early, you could save your costs and keep your project on schedule. Okay, so currently, what happens is clients, they do a spot check, right? You can't check the entire project, during construction. It's just not economically feasible. So what they do is they go out with either a ruler or, typically, hopefully not, or a toll station, right? So they go out with a toll station, they check 5 or 10% of the critical areas, and they figured if that's okay, the rest of the project is okay. Well, that $450 billion mistakes is in the other 90% that they can't afford, that they don't have the time to check. Okay. So with reality capture, we could provide a more complete capture of the project and improve the overall accuracy and point out any deviations much, much earlier. Okay. So what Verity does is it gives your construction managers, your project managers, your field engineers, even your GCs and your subcontractors a tool where they could verify 100% of the work in the same time it takes to do the spot checking, okay? And the key is, as you all know, GCs typically have a contingency fund, and by us pointing out errors earlier on, our goal is that they could maintain that contingency fund and not have to spend it, because that means project overruns and schedule overruns. Okay. So right now, Verity is fully integrated with Navisworks, and I'll talk about why I said right now. So what it does is it reduces risks to budgets and schedules. It gives you a clear indication of the construction quality with as-built tolerance. So for example, if I'm putting up a 10-story building, I want to know there's a problem on floors 2 and maybe even 3. I don't want to wait till I get to floor 5, 6, or 7 to find out I got a problem. So the sooner I find out I've got a construction quality problem, I can correct it and save time and money. By doing that, I increase the project profitability because I minimize or avoid rework, and I can communicate the findings to all the stakeholders. And I could also adjust the model against the point cloud to create a true as-built inside of Navisworks for clash checking. Okay. Now, I said, Verity is fully integrated with Navisworks today. And what I meant by that, we're also developing currently a Navisworks for, a Verity for Rivet. So you actually be able to, instead of Navisworks, you could actually use Rivet and be able to use Verity inside of Rivet. Okay, that's in development. We're planning on having a beta release by the end of this year of that. Okay. So what's the workflow? How does Verity work? Okay, number one, you load your 3D design model into Navisworks. Number two, you load your point cloud into Navisworks. And then number three, you identify and select the objects you want to run. So what that means is this is identified by your scope of work. So if you're an MEP contractor, you would select all the MEP objects. If you're a structural contractor, you would select the structural objects. If you're doing everything, then you would select all the objects, okay? Then you hit the Analyze button and Verity will go to work, and it comes back very quickly with the heat map, just to give you a quick flavor so you could see the overall status of your project. In this case, everything in green has already been installed, and it's installed within the tolerance that you set. Everything in red is missing, so it has not been installed yet. And everything in magenta is occluded. So that means that there's not enough information for Verity to tell. So for an example, if the scanner's sitting here and there's a wall here, the scanners can't see through the wall. So it knows there's objects behind the wall from the 3D model, but it can't tell if they've been installed because the scanner can't see through the wall. And everything in yellow has been installed, but it's out of tolerance. Okay, so here you could see Verity will go through an item by item and show you. So here you could see this is where the item was supposed to be per the design, and this is where it was actually installed out in the field. Okay, so you could see it's color coded. This is where it was supposed to be. Here's where it was installed, so you could see it by color. But Verity also gives you the tabular data, so you could see the actual deviations in the X, Y, and Z coordinates. Okay. This beam, for example, is 188 millimeters out of design tolerance. So if this is cross bracing, maybe it's not such a big deal, but if this is a main steel member, you've got a problem. And the sooner you know you've got a problem, the sooner you could make any adjustments and corrections, okay? what Verity does, it could also produce a report to show you all the deviations, all the out of tolerance items, right? So we could produce a spreadsheet report. We also could produce an HTML report. So the HTML report gives you the 4 different views, right? The plans, sections, elevations, 3D. And for every element, you could see down here, it gives you all your deviations, right? In the X, Y, and Z coordinates. This is a static report that comes, with Verity. We also have something called a Verity Web, which is a dynamic report. So you could actually walk around and see what's going on inside the inside of Verity Web. So all it is you could send a link to anybody with a browser. They could plug it in, and then they could see and walk around inside of it. The static report works the same way. You could send a link to anybody with a browser. Okay. Now, the Navisworks, we could push the same results from Verity into the Navisworks properties. Okay. So here, any member that I click on, I could get data about it here. Okay, so inside of Navisworks properties, any out of tolerance items, I could push that data in and I could look at it inside of Navisworks. Okay. Then we have something also called Smart Points. And what Smart Points is, it shows you what's going on within each element. Okay, here you could see where this beam is connected to the main beam. It's green, which means it's within the tolerance that you set. As you go along the beam, you can see I'm running into a problem, right? So either this beam has a sag or a twist. So there's something going on with this beam. Typically, when you go to the field and you do a spot check, something like this, you wouldn't even pick up, whereas Verity will pick up and show you that you've got some issues. Okay. And the sooner you find out about these, the better it is in terms of keeping your project under cost and within schedule. We could also do an as-built Navis model for class checking. Again, you could see here's where the beam was supposed to be. Here's where it was actually installed. I could click a button and move one element at a time, or I could click a button and move the entire project into an as-built condition. So now I could do, clash detection for Navisworks, inside of Navisworks, sorry. And we also integrate with issue tracking software. So today we're supporting the BIM 360, BIM Track, Procore, as well as PDF reports. And the issue tracking, you could send your structural issues to your structural subcontractors, your MEP issues to your, mechanical contractor. And what they could do is they could upgrade or update that and let you know what's gone on with every single issue. So what this does, Verity, with the issue tracking, it gives you good control and actually better control of your project. And you could see what the trend is. Are you going to be under budget and under schedule? Or are you going to be over schedule and over budget? So it's a very good indicator as to where your project stands. Okay. Before we get into a demo that Trevor's going to show us, I also want to point out that Verity is also used by contractors to verify the design model. Many times, a client will scan a project, then they'll send the scan data to another country, for actually producing a model. What happens is when that model comes back, the contractor may have to spend many, many hours, checking the data that the 3D modeling company in India or in Pakistan or wherever the company is, to check the model to make sure that it matches the scan data. Because a lot of times you're getting a model back and it's not really very accurate. So you've got to check it because you're responsible for it. Verity will do a quick check, show you where all the problem areas are, and you could send that back to your 3D modeling company and say, here's the issues, please correct it. Instead of you spending all the time, you could send it back to your modeling company and let them update that model to make it correct. Okay, so Verity is used for construction verification. It's also used for checking the 3D model against the scan data. Okay, so on that note, I'm going to turn it over to Trevor, and Trevor could take us through a demonstration and show us exactly how Verity works.
Hello, Otto.